Oh, good evening and welcome to what is probably the last video of the organic chemistry series. I'm not entirely sure, I might decide to do another one. But what we're going to do now is have a look at how to name and how to draw some of the more complex of the organic compounds. And you can see from the diagram that it looks quite complex, and from this word it looks really unbelievably complex. So let's break them down and let's see how to name the first one and how to draw the structure of the second one. So, having a look at the first one, well, the very first thing we have to do is look at the number of carbons in the main chain. And so 1, 2, 3, 4, 5, 6, 7. So this is a hep. And I'll just put heptane for the moment, just because it looks like a heptane with a bunch of things included. So let's have a look at the things attached to that 7-carbon hydrocarbon chain. So here we've got a double bond oxygen, and that double bond oxygen is not attached to one of the end carbons, so it's not an aldehyde. It must be a ketone because it's on one of the central ones. And what we do is choose the lowest possible number to name where that ketone is. And so it could be from this end, 1, 2, 3, 4, 5, or it could be from the other end, 1, 2, 3. And obviously the lowest number is at this end. So, whoops, changed my colour there. We'll go to 3, but it's not heptane, it's a ketone. And so we have to erase that E and write -one. So 3-heptanone is what we've got. But we haven't yet taken into account this. And this is one little carbon sticking its neck out there from the rest of them. And I'll label the numbers of the carbon atoms, and that carbon atom sticking out on its own is attached to the 4th carbon in the overall heptane carbon chain. And so what we've got there, the 1 carbon, it is only 1 carbon, so it's nothing more complex than a methyl group. And so we've got 4-methyl 3-heptanone. What a beautiful thing that is. Now let's have a look at this. So it's a massively long word interspersed with numbers. It looks a bit like when you're learning Turkish, you sort of bunch syllables up on each other and build up meaning by adding more syllables. And that's what's been done in this IUPAC name. So let's go from the back to the front, because the ones at the end are generally the ones that shape the structure. So firstly, looking at al. So al, it is an aldehyde. And you know if it's an aldehyde, at the end of it, it's got a double bond oxygen. And that double bond oxygen is going to be attached, well, to something else. The next thing we see is an. So it's a propane or a butane, in this case a nonane. And that means it's a single bond one. It doesn't have any double bonds, it doesn't have any triple bonds, it's going to be single bonds throughout, which is a bit of a relief because we don't have to worry about where to put the double bonds. And it's nonane. So let's have a look at this. I'll change the angle here, and then we go 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's our nonane structure. Now let's see what else it's got. We've already decided that this is going to be number 1 here. And the reason we've decided that is we've called it non-anal. And because it's the al, that will be the first one. Remember, with those, with the aldehydes, we don't bother to say which carbon the aldehyde group is on, because it's always on the first. And so now we have to look at the rest of this. Let's keep going backwards. Chloro, there's going to be a Cl attached to it somewhere. Or di, there's going to be 2 Cls attached to it. And where are they going to be attached? To the 2nd and 3rd. So here we go. There's a Cl. And there's a Cl. So dichloro, 2,3-dichloro. And then we have a look at this, propyl, and that means that somewhere, to carbon atom 5, there's going to be a propyl group. So you might think that would be a 1 carbon, 2 carbon, 3 carbon. But it's not, because it's got this prefix as well. It's got isopropyl. And you might remember that isopropyl looks like this. 1 carbon there, 1 carbon there, and 1 carbon there. So there it is. A fairly difficult sort of problem, but it's all really logical, because the IUPAC name gives you all of the information you need to construct that entire very complex molecule. And, well, that's the last of my videos, I think. I may do another one on cyclos, but I think that will drive you crazy. So let's celebrate and go... Thank you.
Daddy,
what?
You're silly.
What do you mean silly?
And where did that wig come from?
It's not a wig, it's my real hair. I hate you all. Bye.